Welcome everyone. Good morning to the iMobility Forum webinar on VRU safety. I will just give a short overview on our speakers and our moderator, Jean Nomesh from the European Federation of Road Traffic Victims. And we have a lot of speakers today, Jean-Michel Hanchot from Danso, La Nicolau from CEST, Johan Cholier from VTT, Alexei Loreshin from the Lund University, Adria from IDIADA, Federico Fraboni from Unibo, and Dolph Willigers from FEMA. Just a short overview on the interface you see. So this interface allows you to see the presenter's desktop, and on your right there's a collapsible menu where you can adjust any audio or visual settings. If you have any questions, we ask you to type them in the questions panel on the right. The participants are muted during the presentations, but the questions will be answered after the presentation, so please use this chat option. Words about the iMobility Forum. This is an open and independent public-private platform with over 200 organization members. Its aim is to get all stakeholders in Europe together to develop, implement, and monitor work programs linked to roadmaps and international cooperation for the successful development and deployment of ITS. The iMobility support is a support action supporting the iMobility Forum in various activities like stakeholder networking, deployment support, awareness raising, and dissemination of the results. I would like to hand the floor over now to Jean Nomesh, our moderator.
Yes, thank you, Andrea, and welcome everybody. It's raining in Luxembourg, so it's fine that we are sitting in front of our computers, because my wife already shouts at me and she says you are sitting too often before your computer. So I'm happy to be the moderator of this vulnerable road user webinar, and I will also briefly speak what is FAVA, the Fédération Européenne des Victimes de la Route. We are an NGO, mostly with European members, about road traffic victims. So we are very aware that much needs to be done, especially for vulnerable road users, and that's also why I was happy to be a member of the working group under iMobility. But I will directly give the floor to Stella. I think Stella will be our first presenter. She is also the chair of our working group. So Stella, up to you.
Thank you very much, Zenot. Good morning from me as well to everybody. I will just give you some introduction to the working group for your information. Yes, please. Next presentation slide. Working group main objectives that has started in April 2012 and is now 3.5 years old, finalizing its activities along with the iMobility Forum at the end of this year. So that's the last month officially of the working group. So what we had as main objective was to analyze what is happening in the area of vulnerable road users on background data, know-how, understanding of accidents, and what are the near market solutions and trends. What is happening on the terms of studies and researches and projects, supporting the projects and following them, past and new and active ones. Identify what main task was identify the research gaps and priorities for future research, and of course to promote VRU safety in the Commission work programs in H 2020. We have done that both in the 2014 and 15 and 16 and 17 work programs with absolute 100% success, along with the help, of course, of the Research and Innovation Working Group with in the context of the roadmaps, let's say. So yes, please continue. Next slide. So what we have done up to now is we have organized 11 meetings. Last meeting happened a few weeks ago. We had a dedicated workshop on riders and power two-wheeler safety. We had several dedicated meetings regarding the projects that have been finalized on FP7 as well as the ones that are still running. We have 3 connected running projects during the era of the working group, but was PROS that has officially ended successfully. Fruits and the Your Drive that are still running and are with us from the day of their starting. We had joint sessions and events with Fruits project, and we have published the research priorities for 14 and 15, as I told before, and 16 and 17. And we have, of course, fruitful cooperation with other working groups, horizontal working groups of the iMobility Forum, like the Research and Innovation and the Recommendations working group. So as far as from the agenda, Jean-Michel, the co-chair of the working group, and my colleague will present you more or less the idea of what's next and the roadmap, as has been agreed and presented during the workshop of the roadmap of the iMobility Forum. And then we will follow with the presentations of firstly, the current running project of from FP7 at Fruits that is ending, if I'm not mistaken, in March. And then we're continuing with the new projects that have been funded under the 3.4 topic of H 2020 in the previous work program. We have already 4 projects that are here with us. Then we're moving to end users' expectations that Zanot, our moderator, will present. And if Dolph would like also to make an intervention, if he's with us today. And then what is the purpose? We will, at the end, Zanot will moderate let's say a session where we will more or less try to identify 3-4 bullets for the general safety, various safety recommendations for the future. And as far as for the working group recommendations as presented in the last steering group meeting, these are the recommendations that we have agreed and presented and are final. So our main purpose is that we are still believing that we have done a wonderful job in the area of high-level promotion of the various safety through the tool of the iMobility, of course. And we think that this is important, was important, an important networking tool, but all members and also non-members could, of course, had the opportunity to promote their projects and their ideas, and of course their future research initiatives. And of course, the main point is that we don't expect that the various safety issue will be solved by 2020. So various safety and comfort will still have a lot of issues in the future, especially towards the introduction of automation the next years. So that are the recommendations for the working group, but at the end, hopefully here we will manage to also to make it more open towards and mainly on various safety, not on the working group level only. Thank you very much.
Okay, thank you, Stella. So the next presenter will be the co-chair of our working group, Jean-Michel. And meanwhile, if you have questions, you know that you can, on the chat, you can ask your questions, which we will either give you the floor at the end of the presentation or at the very end under the question and answer section. Jean-Michel, the floor. We hear some noise there. Okay,
Noise.
now it's Jean-Michel.
Okay. Do you see my?
Okay.
Do you see my screen?
Yes.
Okay, good. Thank you. So, good morning, everybody. So I will summarize other parts of our work in the PRU working group, and also introduce basic concepts, technical concepts that need to be solved in order to proceed with better safety for VRUs. So, content of my presentation in 5 points. Very quickly, for the people not knowing them, so it's a main Japanese supplier with under 50,000 employees, and created shortly after World War II. And basically, for the product that we are making in our company, and that are related to the activity of providing safety for VRUs. You have different type of radars. You have actuators and computers for ADS, ESC, and control cluster instruments for HMI, and also very much the camera monitoring system. Now, just a summary of the situation of worldwide, the worldwide issue of VR fatality. Basically, in Europe, it represents about 43%, and worldwide about 50%. So it's the major group of fatality that we need to care about. Now, if we consider from a car-centric perspective the issue of VRU safety, it's basically all about sensing, and in that respect, 360 view is not enough, but it's the mandatory step if we want to have integrated and complete safety of the VRUs from a car perspective. What is really important is to understand and to care is that each sensor has its own advantages and limits. And for example, for any front sensor, whether video or infrared or long-range radar, tendentially, the further you want to see, basically, the narrow is the angle of view. Which leads us to typical cases that can much more hardly be colored, like the children coming on the side of the vehicle, quickly running after a football ball, for example. In the other issues that we all face in the car industry, it's to have sensors that can manage not only different type of VRU's detection, but also different weather conditions or lighting conditions. This is valid for any kind of sensor. Basically, the camera-based sensors tend to be to have strong issues with facing sun condition, with flashing lights due to rainy conditions and rain on the surface of the road, or snowy conditions can affect dramatically the detection capability and success rate. So this is the aspect for typically the video-based systems. But radars are not immune from any issue, because, for example, if you have heavy rain, somehow the radar will consider that as a wall in front of you, and basically will disconnect in the early systems that have been developed. So, in summary, there is not the unique radar system sensor that can do everything. It's really a combination of sensors that helps in the end to find the adequate solution. Now, as I said, all sensors are not enough. Direct sensing is not enough. I just found a very nice video. I hope it will. It's a bit tough. You will see it slowly. So the nice group of children that believe apparently that their head is really tough. The kid was really lucky in this case. He just hit the car. Certainly, he's not well, but he's not dead. But essentially, I was showing you this little video because it just shows how much you can gain in terms of time if you have communication between vehicles. In a simple situation with direct sensing, you would have, for the white car coming from the other side, only 0.5 seconds to detect the moving kids and stop the vehicle, which is extremely short time. But in this video, and that was a bit amazing to me, is that if the car having set on its roof, this video would have had a real sensing video analyzing the situation, you would have gained 2 seconds. And 2 seconds is a long time. It can really make a difference. So basically, the message here is the implementation of communication, or CITS as it is known now in Europe, really helps to, would help a lot to improve the situation in very difficult cases. So cooperation is needed at all stages between all stakeholders, but in the end, the integrated an integrated various safety approach is needed. We need to have a better accident investigation, pre-crash, a better VRU use case analysis, soft measures, VRU, the active safety parts with advanced infrastructure technologies, advanced vehicle technologies, and VRU-based technologies to have also with passive safety and cooperation system the integrated safety. Now, when I speak about CITS, we could see lately a very strong move from the motorcycle makers. Motorcycles, we know, constitute a large proportion of fatalities. And they decided, as the main motorcycle makers, BMW, Honda, and Yamaha, to form an alliance to provide by 2020 on motorcycles a CITS unit, basically using V2V technology, and it can really lead also to better integration at different stage. Now, I would present briefly here the VRU safety roadmap that has been developed within the VRU working group, from the scientific research to the industrialization and the different TRL scales, from 1 on the bottom to 8, 9 on the top. And Stella, if you have anything to add, please don't hesitate. So for scientific research, we have the issues of VRUs versus automated vehicle, and also the behavior in mixed environments, the analysis of the incident data for VRUs, the behavioral search, and the specificities of the PTVs, which is a quite fundamental element that is not researched enough. On the technology search, we have the development of concept for integrated VRU protection, the active and ITS safety systems for VRUs, with infra wearables systems, active system safety systems for PTVs and bicycles, all what is about advanced in-vehicle systems, what I discussed extensively just before. Child safety of children and elderly, as well as disabled, as an important topic. Well, I will not go in very details for the other ones. I think that can be read. So, in terms of major RNI topics and challenges, we have in the group distinguished the following list. First, a strong need for incident and near-miss and pre-crash data related to VRUs, which is not very much available so far. Behavioral modeling for each VRU working group, that is a strong point also. Large-scale FOTs related to naturalistic driving conditions to capture VRU-related behavior and ITS requirements. The specificities of PTVs on application and services for their interaction with the other road users. Advanced in-vehicle safety systems and interaction of VRU with automated and non-automated vehicles. ITS safety systems for VRUs and integrated VRU safety. And I think that's all what I have to tell you at the moment. Thank you very much. Leave the floor to the speaker.
Okay, thank you, Jean-Michel. And I can also announce that the presentations will be available on the Ertico iMobility network afterwards, because there was much information, so you can reread this. So next one, Stella, you want also to do a presentation, if I understood well what we discussed before. So.
No. It's included. It's included in Jean-Michel's. It's the roadmap.
It was included. Okay, so the next one will be Joan Cholias, speaking about deployment opportunities and obstacles. Joan, the floor is yours.
Okay, thank you, Jano. So I'm Johan Cholias from VTT. I will introduce you to the Fruits project, which started in 2.5 years ago and will end next March. Andrea, can you give me the next slide? And you can directly go to the next one. So the Fruits project has two major objectives. First of all is to assess the impacts of selected ITS applications and also to provide recommendations towards policy and to industry regarding these applications on how to improve the safety and mobility of vulnerable road users. And as a second objective, we have target to demonstrate some of these innovative services. Okay, can I go next slide? Can you go to next slide? Okay, so in the first phase, we identified a large set of applications which can improve safety and mobility of vulnerable road users. And from these, we selected then 10 applications for a more detailed assessment, which include the services which you see here in red, so blind spot detection, the intelligent pedestrian traffic signal, which modifies the green phase dependent on the amount of pedestrians and give pedestrians longer time to cross. Then there's the cooperative intersection safety, number 5. Number 6 is the automatic emergency braking with pedestrian and cyclist detection. Then we have number 8, the cooperative application for motorcycles. 9 is a VRU beacon system. It is a one-directional cooperative system where the VRU has a device which sends information. The power two-wheeler oncoming system and also number 16, the bicycle to car communication, are two-directional systems in which also the bicycle, respectively the motorcycle, can receive a warning. Then we have system 15 for mobility on the information vacancy for bicycle racks. The crossing adaptive lighting is a system for where crossing is when a pedestrian is on an unsignalized crossing, there is additional lighting or another alert to warn drivers. And the last application is green waves for cyclists. Andrea, can you give me the next slide? Here you see the results of the safety impact assessment. On the left, you see the impact on the different vulnerable road users groups when there is, we assume, 100% penetration. The systems which perform best are the automatic and emergency braking for pedestrian and cyclist detection, and also the vulnerable road user beacon systems. The systems are, the impact is here shown with respect to the total amount of road fatalities for all user groups. Then on the right, you see the reduction of fatalities, assuming the penetration rate which we have estimated in our project. The most efficient system here is the pedestrian detection and emergency braking. Okay, these figures are both for 2020 and 2030. Okay, and this slide shows the trial which we had in Helmond, where we have had a cooperative automatic emergency braking for cyclist application. So the cyclist is detected by radar by a roadside unit. If the roadside unit classifies the signal as a cyclist, it sends the information on the cyclist to a vehicle. Vehicle calculates if the cyclist is on a collision course, and if he detects the potential collision, a warning is sent by the car both to the driver and to the cyclist. The cyclist receives a warning both haptically by vibrating handlebar and by visual warning on a screen. Okay, then the next slide, please. In Spain, we have had 2 trials on pedestrian crossings. In the city of Valladolid, there was a crossing from a pedestrian zone with road, and there the traffic signal was adapted based on the number of pedestrians waiting. In addition, there was increased illumination of the crossing. This crossing resulted in a reduced number of traffic inflictions and reduced waiting time for the pedestrians. In Alcalá de Henares, we had a system which consists of several components. First of all, there is a Bluetooth connection so that pedestrians who arrive near to the traffic signal don't have anymore to push the button, but are automatically detected when they come near to the traffic post. Then they also have the possibility to use a mobile application which provides information on how much time they have to wait or remaining time to cross. And then the vehicles are warned in case there is a pedestrian crossing. This is especially needed there because for pedestrians turning right, they don't have clear visibility to the crossing. And in addition, there is also increased illumination, both to improve the detection of pedestrians at the crossing and to increase the safety of the pedestrians who are crossing. Okay, can you give me the next slide? Okay, so based on the results of our assessment and of the results of the pilots, we determined which are the barriers to implementation and how they can be overcome. We come to a set of recommendations which are also in line with the recommendations described by Jean-Michel. There were some recommendations regarding research on that the technical performance of the detection, classification and the tracking, both by sensors in the vehicle and by the infrastructure, still has to be improved. Then there is also what was mentioned by Jean-Michel, that there is more information needed on the road users' behavior, both for modeling, so that the intentions and the coming tracks, the movement of the vulnerable road users can be predicted more in detail, but also on knowledge on how the road users interact with these systems. Then there is research needed on the optimal user interface, both for in-vehicle drivers, especially for elderly, but also for how can vulnerable road users, how can pedestrians, cyclists, motorcyclists be warned. Warning them through a smartphone is not an optimal solution. Should be alternatives. How can we do that? Should we integrate it the device direct in the bicycle or a helmet or a vest? And how to present this information and warn the drivers with less distraction. Then there are field tests needed to understand how the vulnerable road users will interact with these systems, and especially long-term durational tests in order to check for any behavioral changes, for instance, due to over-reliance to the systems. And also these tests are needed to provide more information on benefit limitations and costs, so that this can result in investments from, for instance, cities and authorities for these systems. Okay, next slide, please. Okay, then we have also some recommendations on the different cooperative functionalities, for instance, the green wave for cyclists and the intersection safety. The devices for these applications could be integrated in a single device if they all use the same communication technology. Then for traffic light control, there are severe possibilities for improvement of traffic light control, for instance, to reduce the amount of traffic inflictions. But this requires first to have an overall view of the traffic and also to detect both the vehicles and the pedestrians and to optimize the traffic. So that improves the mobility of especially the vulnerable road users, but without affecting negatively to the mobility of the vehicles. Then there was a suggestion to legislate the blind spot detection for trucks and buses. Then also privacy was discussed, and there should be the proper procedures should be followed for data collection and storage and use of the collected data. These are the first recommendations that will be further analyzed, and then we will come to the end of the project, and I would like also already to invite you to the final event of our project, which will take place on the 3rd of March in London. And at our website you can also sign up for our newsletter. And we would like to have your feedback on the recommendations, and if you sign up for our newsletter, we will contact you for your feedback in the beginning of next year. Okay. If you have any questions, please type them in the chat section. Thank you.
Okay, thank you, Johan. I think the date was wrong for the final event. It's 2016, of course.
Yes.
That was to show that I read very carefully the presentations. So, and I can also agree what Johan said. I was also attending last week's interest group workshop in Brussels. There's really a big interest now on vulnerable road users safety, which was not the case 20 years ago when I started to be interested in all these road safety and road danger reduction topics. So our next speaker will be Alexei Laurishin from the Lund University. So Alexei, please go ahead. Alexei, we're still there? No, we lost him. He was online before 11.
Can you hear me now?
Okay, now it's fine. Okay, go ahead, Alexei.
Yeah, sorry. Well, I'm the coordinator of the project INDEF, and this project is relatively new. We started only in May this year, and the idea is to kind of integrate the different methods that are used for studying the safety of vulnerable road users. Traditionally, it was very much focused on accident data, but we know that it is a problem that vulnerable road users are underreported. Accidents with them are underreported. And we have figures, for example, from Denmark, only 7% of cyclist accidents are ever registered. So basically, it's a huge dark number that we never know what kind of accidents, what kind of injuries was there. So we want to put together different methods, different types of data, and hopefully to see a bit better picture of the problems and even what the solution can be. So we are looking at traditional accident data, and here we combine police records and medical care data. We look for in-depth investigations of accidents, for example, GIDA's database in Denmark, and also some other countries have their local databases. We work quite a lot with traffic conflicts and observational studies. And here we see quite a big potential because accidents, well, the data from accidents is always the final result. You never see how the accident actually happened. But if you look at traffic conflicts, we believe that the process is quite similar, and we can see the contributing factors that otherwise are not reported to the accident databases. We can see them in traffic conflicts. For example, like it was another car obstructing the view, but it was not involved in an accident and it just moved away and nobody told about it. We will use self-reporting of accidents, sending out questionnaires to the same panel group. And the idea here is that we will get a better understanding of how many of accidents are actually not reported. So of all the accidents that the panel will report to us, we will check how many of those actually are registered in accident or in medical care databases. We work with naturalistic cycling and walking, and here the idea is to have quite simple tool, but that can be scaled to quite many users. So we are aiming at a mobile application that will send some kind of a signal warning when it believes that it was some kind of fall or rapid acceleration, deceleration, and after that we will contact the person and ask him to explain a bit more what actually happened. And the final part of the project is further specification of the costs related to vulnerable road user accidents. And again, here, for example, underreporting is very, very important factor, because if we don't know that accident happens, we don't know how much cost that involved. And if you go to the next slide, please. Yeah. So except for the methodological development, we will also have several technical tools developed in the project. We have an engineering team in the project as well. And what we will work with is primarily collection of data on sites where we expect to have vulnerable road user accidents. We will collect video during quite long periods, and also not using only video or only one camera, but we want to combine different sensors, several cameras, and even thermal cameras, radars, test different types of sensors. Then the next step is, when you have all the data, how to use it, and we will develop the video processing tools for that. It will be both a simple tool, watchdog, that can work quite quickly, process the video more or less in real time, and also more advanced tools that will be able to track the road users in video and extract their trajectories and provide more detailed data about how the interaction is going on, what was the speeds when they start braking, when they start accelerating, and so on. And on that picture you can see an illustration. That's that type of analysis of traffic conflicts that I am particularly working with. And the third technical tool is the mobile application that will be used for naturalistic studies. So it's a tool that will analyze the data from the sensors in mobile telephones and send some kind of signal when it believes that it was some kind of traffic-related incident, either it was a fall or a collision. And as I said, can I just press once again, go to next picture? Yeah. So as I said, it's a new project. We don't have so much information available yet, but we will send out our first newsletter in the beginning of the next year, and all the reports, all the information will be available on our homepage, and you are most welcome to visit.
Okay, thank you, Alexei. Of course, data are very important in all domains of road safety, and especially also for vulnerable road users, and also under reporting is a topic. So our next speaker will be Adria Ferrer from IDIADA. So the floor is yours, Adria, or the screen.
Yes, thank you, Janel. Yes, so I would like to present a couple of projects such as the one that Alexei presented, such as INDEF, are really new projects. They started one in May and the other one in June. So there are not many results yet, but the approach and the concept of the project and the work plan can be presented as well. Both projects have in common that the main scope is vulnerable road users for both, and also they are basically studying vehicle-based technological measures. So technological measures to enhance and to ameliorate the safety of vulnerable road users. One of the projects is more active safety related, and the other one is more passive safety related. Can I have the next slide? Okay, so basically as a short introduction, and just to show how technology has contributed to vulnerable road user safety, as it was presented also in the presentation from Denso. We have, for example, in the graph in the upper left part of the slide from Fredrickson and Rose in 2011, the effectiveness of technological measures. So for active and also, but for passive safety measures in cars and also integrated. So we can see that even both, so even only passive safety measures has a high effectiveness already for vulnerable road users, namely for pedestrians in this case, but also active and more importantly integrated safety measures has a huge impact on pedestrian safety. Also from the Aspects project that was mentioned as well and was presented in this forum some weeks ago, we can have some benefit estimations that were as results for the development and implementation of some of the systems. But also in the lower left part, we can see that up from the Thorax project in 2010, it was stated that up to 37 million euros could be an expected benefit considering age-dependent risk scores. So we will be talking a lot about pedestrians, but also one of the projects is quite related to elderly, which are by themselves already a vulnerable road user group, but are also considered as pedestrians in this project. So if we can have the next slide. So I'll be mainly talking about seniors and prospect. I've also introduced X-Cycle just to leave the floor prepared for Federico Fabroni. So starting by Prospect. Prospect is a project, it's namely proactive safety for pedestrians and cyclists. So it's basically, it focuses on the development of the new generation of autonomous emergency braking for pedestrians and cyclists. It builds upon the results obtained in the Aspects project, so that even the consortium, the core part of the consortium is similar, and the results will be used to go further and build, as I said, the next generation of these systems. And it's closely related as well to the application roadmap of the Euro NCAP protocols. So many test methods and assessment methods will be developed as well in the project so that this can be implemented in Euro NCAP. 5 main objectives were defined. So first would be to a better understanding of relevant vulnerable user scenarios. It was, and I will use here the Denso presentation. It was mentioned that it's really important to come from the origin of these systems is the accident data. So to identify the most critical use cases and to better define the scenarios these systems have to address. So that's why this will be a first part of this project, basically based on data from GDAS, from IGLAD, from monitoring hotspots in different European cities by performing naturalistic studies as well. So we will see accidents, but also critical situations that doesn't end up into accidents, which was said also it is a lack in the current research we have. The second objective would be to develop improved vulnerable user sensing and situational analysis. So as I said, better sensors that can identify critical situations in a wider range of scenarios than right now. Also, as a third objective, there's the advanced HMI and vehicle control strategies, so different warning or more effective warning strategies, but also different vehicle control strategies. So, for example, combining braking and steering in case of a critical situation. In the video, and I come back again to the Denso presentation because it's closely related to this project, the video that was shown, it's true that connectivity and communication between vehicles could solve or could have a clear benefit in this type of situations, but also combining, for example, braking and steering could have a clear benefit. So this type of actions and strategies will be studied here. And then at the end, we will have 4 vehicle demonstrators, which includes a mobile driving simulator and also a realistic bicycle dummy demonstrator for assessment and testing will be developed. And at the end, all the technologies that will be developed will be tested in realistic traffic scenarios, and there will be also a user acceptance study, which is completely key for the implementation of these systems, so that, for example, the user doesn't turn off the warning system and so on. Just to mention also that this project is, as I said, is highly, we can say, technological oriented. There are 5 OEMs on board and 2 tier 1s, so the industry is highly represented in the project. And the idea would be to develop and try to work for the implementation of these systems that we believe can have a really high impact for the mainly pedestrian and cyclist safety. Coming back to the other project, which is the seniors one, as I said at the beginning, this is a project focusing on another type of users, which is elderly. So as we said from the last slide, elderly are already vulnerable users inside the cars, not only as pedestrians, but also inside the cars, as the frailty is much different for an elderly human body than for a young one. So we will study elderly from an integrated point of view, including vehicle occupants, namely passengers and drivers, but also as pedestrians, because usually elderly are more pedestrian than drivers or car occupants. So this will be studied, but also we'll take a look at public transport issues and safety-related issues. So the main objective would be to improve the protection of elderly road users as vulnerable road user in an integrated approach under the consideration of the most relevant transport mode, as I said, so inside the car and outside the car, or even inside other public transport modes. We'd like to identify the differences in dynamics for different road user ages, age groups, and pre-crash in the pre-crash and crash phase. So volunteer tests will be performed to identify and compare between elderly and younger people to identify the kinematics inside a car during the pre-crash and crash phase using existing data, but also, as I said, volunteer testing and PMHS tests. The identification of anthropometric and injury mechanism peculiarities of elderly, including obese people compared to younger people. So, for example, here, one of the main one of the important workloads in this project would be the biomechanical part. So biomechanical differences between elderly and younger people will be studied, not only in cases of injury risk scores and so on, but also in case of kinematics, as I said. During the proposal preparation, we identified also obese people because obese is closely related to elderly. So the older we get, the more body mass, the higher body mass index we have. But the first results show from Maxian data and body mass index in several countries shows us that this is not a main issue. So the project will not go deeply into the obese people problem. And finally, we have another objective would be the development and optimization of test tools, procedures, and assessment methods with special regard to elderly and obese. So we will develop new testing methods for pedestrians, for example, but also new assessment methods for occupants in always speaking about the passive safety side, so crash tests. And at the end, we'll have so we have already a really strong cooperation with the US and Japan mainly. We had an event in Lyon in September, in which many people from University of Virginia, NITSA, and other stakeholders from the US came and gave their opinion on the project approach, and we could identify some collaborations, but also people from Japan, from Yari, for example, were there, and many activities will be organized there in parallel to the seniors project. Finally, I'm just leaving here in the slide the information for the coordinators, so websites of the project for prospects and seniors, and the coordinators. So the coordinator for prospect is Andres Aparicio here from IDIADA, and the coordinator from seniors is Marcus Vies from BAST, and well, I'm acting as project manager for seniors, so that's why I am presenting here. And as we have X cycle on this slide, I will give the floor to the next speaker, which is Federico Fabrioni.
Okay, Federico.
Hi to everybody. Can you hear me?
Yes. May I ask you also as moderator to be short, because we are running out of time. I don't know if we are allowed to go a little bit over 1 hour, because we were supposed to end at lunchtime, and for the moment there are no questions, but if there would be some questions, that would be fine too. Okay, thank you. You have the floor. Go ahead.
Okay, thanks. First of all, I would like to say that there are construction workers exactly in the upper floor of my room. They are draining the floor, so maybe there will be noise. You can hear it, maybe. I'm really sorry for this, but I can stop that. I hope you can hear me. And also I would like to thank Andrea Ferrer for mentioning X-Cycle project, which is very nice for us. And the title of the project is Advanced Measure to Reduce Cyclist Fatalities and Increase Comfort in the Interaction with Motorized Vehicle. Basically, we are focusing on cyclists because they suffer a disproportionate share of serious injuries and fatalities. And indeed, in recent years, the disadvantage has been growing. So, X-Cycle is a RA type of action, RIA, Research and Innovation Action in the Horizon 2020 program, and that has a duration of 42 months. We are in the month 6, so we are basically in early stages of the project. There has been a meeting in Linköping, in Sweden, right now, 2 days ago, consortium meeting. So, as Dr. Ferrer said, this is our website with a lot of information about the general aim of the project and news about the developing of the studies. Main objectives are to improve cyclist safety in the potentially dangerous interaction with passengers and cars, and to develop the means to equalize the treatment of cyclists in traffic, and both encouraging cycling and make cycling safer. So the X-Cycle project will develop technologies aimed at improving active and passive detection of cyclist systems, informing both driver and cyclist of an hazard at junction, effective method of presenting information in vehicles and on-site. Also cooperation systems aimed at reducing collision with cyclists. So we have a lot of aims in common with other projects. Main cases we would like to study are bicycle interaction with cars and heavy good vehicles at the intersection, and provision of immediate or extended green traffic light for cyclists. There will also be a behavioral evaluation of the whole process, and we also going to develop a gender and age analysis on the accident on the road. The team in Unibo is University of Bologna is the coordinator, Professor Luca Pietrantoni, and also other professors like Marco De Polo, Brunazzani, Marco Mariani, and Gabriele Prati, which is doing a lot of work for the project. And also Marco De Angelis is another collaborator for the Department of Psychology. And we have the engineer and electronic department with Davide Tardari and Nicola De Carli. The consortium, this is also other staff members of our team, and our consortium comprises also other organizations like the University of Leeds, Volvo Truck, DLR, University of Groningen, VTI, Intec, Kite, and Genoptic are the other partners in the project. This graph shows all the work package of the project that we are developing. Right now, we are especially focusing on work package 2, problem specification and solution, and work package 3 and 4, in vehicle and vehicle system and infrastructure-based situation and threat assessment. And basically, this is all, because we are also running out of time. I'm really sorry for the noise. I hope you heard me well. And if there are questions, you can ask.
Okay, no, we could hear you very well, Federico. There are 3 questions maybe that we can try now to answer them. The first one is, hi, I'm interested in what message standards will be used to broadcast information on moving pedestrians. Is any one of the panelists who can help with this issue?
Well, basically, on X-Cycle project, we are focusing more on cyclists, more than pedestrian.
Okay. And then another question, question 2. My question is about slide 7. The pedestrian needs to stand next to the light, and the Bluetooth sensor sends the present and light automatically in green for the pedestrian for walking.
Johan here, yes, so it works. So with Bluetooth you can set the area to different levels, and so it should, when you can select so that it's that the distance is to about 1 meter, so because you have to set the field optimal, so to avoid any false alarms.
Okay, thank you, Johan. I'm still waiting for the third question, but meanwhile I see that all the attendees are still there. I could quickly go to what I prepared to my presentation, but it will be very short so that we will have time to screen sharing, show my screen. That's the first time. Change presenter. It doesn't work. Or maybe Andrea, you can do it for me, the 4 slides. And I also assume that if there are other questions that you can send them by email. Okay, there it is. By email to Andrea, who will forward it to the different presenters. So I will be very short. Of course, vulnerable road users, we are especially looking also at pedestrian and cyclists, and especially children and elderly. So I was also very glad to hear in the last presentations that the elderly are not forgotten, to have safe mobility. Next slide, please. So much was said about cooperative systems. Andrea, next slide. Thank you. In-vehicle systems, infrastructure-related systems, but I will also ask, what about ESA? ESA is intelligent speed assistance or alcolog, or even event data recorder. There's a famous black boxes, because if we have more data, maybe event data recorder could also help on this. And of course, we need a holistic approach. It's not only ITS, which helps, but also the infrastructure, and also the people who need to be informed how the different system works, and also to do some sensibilization, and of course, last but not least, also enforcement. Next slide, please. Of course, children, as I say, are the most vulnerable, and there I was very much happy with Pyramid, which was done by ETSC, the European Transport Safety Council, where we are a member of the board. That first come pedestrians and cyclists, and then motorcyclists, power two-wheelers, and then those who are more secure or are more safe. As I said before, much has been done for vehicle safety, but now also we see that much will be done also for those outside the vehicles. And then the last slide, please. I was also in Brasilia for the high-level conference on midterm review conference, and there this final outcome was that the safety of pedestrians, cyclists and motorcyclists is seen as a priority. So also worldwide, not only in Europe, much more is now considered that vulnerable road users are also important. That's all for my presentation, and then we come to our last speaker. It's Dolph, who wants to speak on behalf of FEMA. Dolph, are you there? I have to... Hello? Screen share. Dolph? No? Andrea, could you help me?
I see Dolph, he's unmuted, so we should be able to hear him.
Okay, Dolph, if you want, you can do your short presentation, and then we will quickly move to the question and answer section if there are some more questions.
I didn't prepare a presentation.
Dolph, maybe you can make your microphone a little bit louder. The level is a bit slow.
Is this better?
For me, it's just a limit. Maybe if you have another decibels to...
Well, I'll try to do something about it.
Okay. Dolph.
You have to deal with how it is now. Today we will focus on visibility or conspicuity of motorcycles, because that's a cause of many accidents. Visibility is caused by size and form of the motorcycle, the expectations of the other road users, and estimation of the speed of the motorcycles and also of the mopeds, by the way. How can we better this? That's by the motorcyclists can do something by themselves by wearing contrasting colors in the clothing. That doesn't mean bright colors, but it must be contrasting. To take a good position on the road, maybe move a little bit from left to right. That helps also. And use lighting on the motorcycles, and in this respect, the new type-approved regulations that come into that are implemented next year will have head-on lights mandatory for new motorcycles. Then the last thing is the ITS and the connected ITS measures, which, by the way, are no replacement for bad car design. Many cars these days are designed in a way that it's hard to see other road users like bicycles and motorcyclists. But to observe motorcycles better, CITS is a way to do it, and fortunately, some manufacturers, they are already mentioned by Michel, like Honda, BMW, and Yamaha, are working together to do this, and I think this will lead to global standards, and that's a good thing. And the other thing that's important in that respect is the penetration degree from the devices on the motorcycles. You have to take into account that cycles is much longer than for a car. You could talk about 25 to 50 years sometimes. So that's what we expect, that CITS can be a way to enhance visibility, and we are looking forward to that. Thank you.
Okay, thank you, Dolph. Andrea, I need again your help because I lost the chat section. Are there any other questions? Maybe you can read them to the presenters and to whom they should be addressed.
And I just checked. No, not at the moment.
So we could quickly come to the recommendations. If I can resume what I wrote down, of course, in former seminars also we heard much about avoidance, so the pre-crash. The best situation is when there is no crash at all. That could be a recommendation, so that all those systems who help to avoid a crash are even better than having a crash or having a crash with a less serious outcome. And then another topic was also mentioned several times, that the road user behavior, the real world interaction should be better understood, and also in user interface, we need better data, realistic traffic scenarios, but also the user acceptance is important. So that could be a recommendation to look more at this. And a third topic, which is for me very important, that's also the serious injuries. We did much research about, or speak much about fatalities, but especially in urban areas and among vulnerable road users, there are many serious injuries, also especially about the elderly. So that's what I had more or less written down. But if the other presenters or Stella has some suggestions, so that we have some bullets on open recommendations. Is there any one of our presenters?
Yes, I would like to tell, because maybe it slipped me away during the presentation, that we are gathering a lot of data in the X-Cycle project from all European countries on serious injuries and accident condition, and we have a pretty serious amount of data right now, and we are elaborating it.
Okay, yeah, because data are very important, or if we have no data, through underreporting, so especially also among vulnerable road users.
Okay. Johan here,
yeah, sure.
we have taken also in our assessments the serious injuries into account. The problem, which was also addressed by Alexei, is that there is a severe underreporting dependent on, and there also a different interpretation of what is a serious injury. So the figures for fatalities are much more reliable than the figures for serious injuries.
But we are making progress. Also, the European Commission is for having this strategy. This morning, as I said, I just read the newsletter of the Commission, which is also speaking about serious injuries, to have better data. And for us, also for our federation, it was also important that if we speak about road traffic victims, we don't only speak about those who died, but also those who get serious injured, and with all the problems arising for our whole life. Okay. Some other suggestion from one of our panelists? We are a quarter, it's a quart d'heure academic, a quarter, but most of the attendees are still there. Ask again, Andrea, is there any question?
No, not yet.
At the moment. Okay. I have also a final remark. I heard often speaking about accidents. We and many other stakeholders also prefer to speak about crash or collisions or incidents in cause of accidents, because accident would say that it could not have been prevented. And as we can see, most of the so-called accidents can be prevented also among vulnerable road users. Stella, you want to say a final word as our chair of our working group? No, Stella had left. So I will thank all those who were listening to our webinar, and
Hello?
especially also, yes?
Hello, can you hear me?
Yes?
Yes. Now.
Okay, okay, sorry, because sometimes I don't know what happened. I am here all the time. I didn't leave.
Okay, fine.
Okay, just to close, I would like to thank you everybody for attending this webinar. We tried a little bit to show more or less the past, the present, and the future of VRU safety. So it would be very helpful for us because we are preparing a final report and 2-page recommendations that will be included in the whole iMobility Forum final report. But we receive what is your personal 1 or 2 bullet priorities for recommendations for the safety. So beyond what you saw from the projects today, what do you think what will be the problems for the future? What could be potentially the next research areas or gaps that we will face towards the next years? So that would be very helpful if you could send it to us, because that will be included after, of course, some coordination and prioritization at the recommendations final report. So your input is really valuable. Thank you very much, Zanot, for moderating this session perfectly. Thank you so much. Many thanks to all the panelists and presenters. Thanks also to Ertico for hosting us and supporting us through the iMobility Forum. And of course, the last but not least, many thanks to my co-chair, Jean-Michel, that has supported all the time that we are together, this working group, and made it really successful throughout its duration. So that's all from me. Thank you very much. Zanot, it's your, I don't know.